When we're evaluating functions for given specific values, what you want to be careful of is just the signs and your parentheses and your exponents, your absolute value bars. Just be very careful with the arithmetic. So what you're doing, so for instance, for number 17, let's do this one together. We're trying to find the value of k of 4 minus g of 2. So what we're going to do is first we're going to evaluate k of 4. What is k of 4 equal to? Well, k of 4 is equal to, and then I take a look at what is my k function. Well, I replace the x with a 4. Everything else is going to stay the same. The absolute value, the -3, the -10, all of that stays the same. The difference is that I put a 4 in the parentheses. I substitute a 4 in place of the x. And now I evaluate. -3 times 4 is -12. We'll subtract 10, but that was absolute value -12. Remember, the absolute value is a distance from 0. The number -12 is 12 units away from 0, so the absolute value of -12 is 12. When we subtract 10, we're left with 2. 12 minus 10 is 2. So that tells me that k of 4 is equal to 2. If I were to write that as an ordered pair, remember the x value was 4. We substituted x with 4, and the y value, the output, was equal to 2. That's not what we're solving for, but again, keep in mind that that's exactly what's happening. Now, g of 2, we're going to do very similarly, but it's just a different function. Where is g? He's this guy. -6x squared minus 6x. -6x squared minus 6x. Notice every time I needed an x, I put parentheses and I'll substitute in that value. So 2 squared is 4. Oop, let's multiply it. And -6 times 2 is 12. -6 times 4 is -24. And when I subtract 12 from that, I'm left with -36. So g of -2 is equal to -36. And this is an ordered pair. X value is 2. My output is the y value of -36. What we were asked was what is k of 4 minus g of 2. So we're going to take those two values, 2 and -36, and we're going to subtract them. 2 minus -36 is equal to +38.